I have always been interested in how things work. I used to take things apart to see what made them tick, but I wasn't so good at putting them back together again. But I think most children are like that. They ask how things do what they do, and why. I am still looking, but I have helped find some of the answers. In this film, I would like to share with you the story of how science has unraveled the greatest mystery of the universe: its creation. Our universe is a vast and splendid place. Our planet, the Earth, circles one of 100 billion stars in our galaxy. And our galaxy is just one of 100 billion galaxies. This great space is our home. Yet 14 billion years ago, none of this existed. There were no planets, no stars, and no galaxies. So, how did the universe begin? How did we get from nothing to all the astonishing and beautiful phenomena we now observe?
Since earliest times, there has been a passionate debate about the origin of the universe. Most religions claimed that the universe was very young. For a long time, Christians believed that it was just 6,000 years old. As fossils and other evidence began to emerge showing how much older planet Earth was, this no longer seemed credible. Estimates for the age of the universe as a whole must go much further back in time, though no one was sure exactly how far back. It seemed to make more sense, therefore, to suppose that the universe had always existed.
By the early 1900s, most scientists assumed this to be true. What's more, they believed this eternal universe had always been much the same as it is now. It was static and infinitely big. According to this conventional view, there was no beginning, and nothing very exciting ever happened.
All this, though, was turned on its head by one of the most astonishing discoveries of the 20th century. In the late 1920s, the American astronomer Edwin Hubble made a series of observations that startled the world.
My colleague, Neil Turek, tells the story.
What Hubble did was to use the most powerful telescope in the world at that time, the Mount Wilson telescope, to make a very careful study of galaxies and stars. What Hubble found is that all the galaxies around us are moving away, and as you go further from us, they're moving faster and faster away from us.
The discovery came as a huge surprise. The universe wasn't static at all. It turned out that all the galaxies in space were steadily moving apart from each other. This would be a crucial clue as to how the universe began.
Here we have a model of the universe in which every star represents either a particle or a galaxy, and the universe starts out very small and then it expands. And what you can see is that as it expands, every star moves, or every galaxy moves away from every other galaxy. So there's no center of the expansion, it's just that everyone is moving away from everyone else.
This astonishing discovery shook the foundations of cosmology. If the universe had always been expanding and you traced its progress back in time, then the early universe had started very small. The universe may even have had a beginning, a moment of creation. Despite Hubble's discovery, nearly all scientists ignored the question of what had happened at the beginning of the universe. The problem seemed too difficult to tackle. But after World War II, a small group of nuclear physicists began to take the idea seriously and tried to imagine the conditions at the beginning of the expansion. The man who led this quest was the Russian exile, George Gamow.
He was a nuclear physicist, well known for his imaginative ideas, wonderful insight, but never got a calculation right in his life, as far as I know. And he came up with the wonderful idea that the early universe might have been very hot.
Gamow considered the possibility that the early universe closely resembled an exploding atomic bomb. It was very hot and very dense. As the universe expanded, it would cool and create the basic elements of nature, such as hydrogen and helium. But his theory wasn't taken very seriously. His opponents dubbed it the Big Bang Theory. But Gamow and his colleagues made a remarkable prediction. They claimed a remnant from the hot Big Bang, in the form of microwave radiation, should still be around today. It wouldn't be strong enough to defrost a pizza, but it would be all around us. At the time, no one thought the radiation could be detected, so the idea remained just an idea. But later, it would return in triumph.
I became interested in the Big Bang Theory shortly after I came to Cambridge in the early 1960s. At that time, many scientists were still instinctively opposed to the idea that the universe had a beginning. They felt that a point of creation would be a place where the laws of science broke down, and one had to appeal to religion and the hand of God to determine how the universe would start off. They therefore looked for alternative explanations.
One idea that may sound unlikely was that the universe bounced. It moved from small to large and back again, and just kept doing that forever. In this scenario, the universe had always existed.
Whether this was true or not was clearly a fundamental problem, and just what I needed to complete my PhD thesis. In this, I showed that the universe cannot bounce. Instead, it must have begun with the Big Bang. This result upset many physicists, but it delighted those religious leaders who believed in an act of creation, for here it seemed was scientific proof. I had shown mathematically that the universe must have had a beginning. My colleagues and I were now waiting for the observational evidence that would prove this to be true. The discovery, when it occurred, was a result of a complete accident.
In the United States, two scientists, Arno Penzias and Robert Wilson, were testing a radio receiver built for microwave communication signals when they detected an unknown source of noise. Nobody could work out what it was, but 20 years earlier, Gamow and his colleagues had predicted a similar noise.
Penzias and Wilson weren't at all interested in the Big Bang or cosmology and had no idea about Gamow's prediction. They discovered in their antenna some noise that they couldn't explain. And they worked for many months to try and remove the source of the noise by fixing the joints and cleaning the antenna. Couldn't get rid of it. Then by chance, one of them had a conversation with a cosmologist who was thinking about Gamow's idea and the hot Big Bang. And instantly they realized this is what they'd in fact discovered.
Gamow and his colleagues had been correct all along. All around us is microwave radiation that comes from the birth of the universe.
This discovery was one of the most important in the history of science. We made a great leap towards discovering how the universe began.
This is how we think it happened. It started with a Big Bang. A moment when the universe was thought to have had zero size and to have been infinitely hot. As the universe expanded, its temperature dropped. In some areas, galaxies formed. Within them, smaller clouds of hydrogen and helium gas collapsed to form the first stars. The universe began to fill with light. When the stars burnt up their fuel, they blew up in a tremendous explosion called a supernova, throwing new elements like oxygen and carbon out into space.
This dust from the stars is spread around the universe. It formed the planets, including the Earth. You, me, and even my wheelchair are made of stardust. The Big Bang Theory was incredibly successful at explaining the evolution of the universe. But there was still a problem. It didn't answer the fundamental question. It didn't explain how the universe began. What triggered the Big Bang? For a long time, nobody could think of an answer. But then an extraordinary idea was suggested that would take the world of physics by storm and solve the problem. By the 1970s, nearly all scientists agreed that the universe must have originated in a Big Bang. But the Big Bang Theory left many questions unanswered. Above all, it didn't explain what had started the Big Bang itself. What could make something infinitely small expand into the vast universe we see around us?
When the answer came, it struck everyone as elegantly simple. American physicist Alan Guth proposed a solution. Guth was investigating what happened in the first microseconds of the universe. He suggested that the universe expanded at a faster and faster rate. It would have been like the way prices go up and up at an accelerating pace, so Guth called it cosmic inflation. But inflation in the very early universe would have been much greater than anything on Earth. in a fraction of a second, the universe would have expanded to a trillion times its size.
That's no ordinary expansion. And so the explanation would be no ordinary one either.
In Guth's theory, the expansion of the early universe would have been caused by a strange type of matter, which behaved very differently to the ordinary matter we are familiar with. Since the days of Isaac Newton, it has been known that ordinary matter attracts other matter through the force of gravity. This is why things fall to Earth. But the new type of matter behaves in the opposite way. It repels itself. If the early universe was filled with this type of self-repelling matter, everything would be pushing against everything else, and that would account for the sudden expansion of the universe. Very quickly, the exotic matter decays into hot radiation and ordinary matter. This is the fireball of the hot Big Bang. The universe is born.
At last, it seemed, we had a complete explanation of the beginning of the world. But our hopes were premature. Inflation theory provided a nice mechanism for driving the expansion of the universe, but it also raised a new problem.
Early inflation theory suggested what the universe would look like. It would be completely smooth. In other words, matter would be distributed evenly through space. That may sound sensible enough, but that's not at all what the universe is really like. It happens to be made up of the clumps of matter we call galaxies. What was needed was a mechanism by which the early universe could create galaxies.
It was a problem I felt I could answer. My colleague Gary Gibbons and I had earlier proposed that an inflating universe would contain little thermal fluctuations, which would be blown up as the universe expanded. In 1982, I pointed out that these fluctuations might provide the means by which galaxies could be created.
It was a satisfying theory, and if true, it would be the last piece of the jigsaw, the missing link between the birth of the universe and the world we see today.
But were we right? As a physicist, the work I and my colleagues do is largely theoretical and often can't be tested against observational evidence. But 20 years after we came up with our prediction, physical evidence appeared.
In June 2001, NASA launched a satellite called MAP to make a detailed survey of the cosmic microwave radiation thrown out at the birth of the universe. If the thermal ripples we suggested really did exist, they would show up in the images produced by the satellite. And here's one of the photographs. Astonishing as it may seem, this is our earliest view of the universe, showing it as it was over 13 billion years ago. The photograph captures the patterns made by the microwave radiation, which was produced by the Big Bang. Radiation that still exists right now. In the picture, you can see the thermal ripples that we suggested would exist. Their type and size is exactly as predicted, and they form a pattern that corresponds to the galaxies we see today.
The theory had been confirmed. The last piece of the puzzle had fallen into place. For the first time in human history, we are able to describe how this world we see around us came into being. Our theories take us back to the time when the universe was born, but people always want to know what came before. There have been various ideas, but for me, the most attractive is that the universe was spontaneously created out of absolutely nothing.
This may sound like magic, but such creation is possible. One way to picture the origin of the universe is to imagine it as like the formation of bubbles of steam in boiling water. Tiny universes appear spontaneously out of nothing. Most of the universes collapse to nothing, but a few, like ours, will continue to expand and will form galaxies and stars, and maybe beings like us. Centuries ago, the astronomer Copernicus shocked his contemporaries when he revealed that the Earth was not the center of the solar system.
Scientists like myself are now ready to accept that our universe may not be anything special or significant. Except, of course, the way that it is constructed has led after 14 billion years to so-called intelligent beings who can ask the question, why is the universe the way it is? The answer is that if the universe were more than slightly different, no one would be around to ask the question,